So I want you to imagine for a second that you've just hired, like, the most brilliantly smart assistant on the planet. I mean, they've read every book, they know every coding language, they can synthesize years of market data in seconds.
Sounds like a dream hire, honestly.
Right. But there's a massive catch. They just sit there at their desk, staring blankly at you, completely frozen, until you walk over and tell them exactly what to do, step by step.
Ah, the classic prompt problem.
Exactly. You have to prompt every single move they make. But the thing is, today, that blank stare is gone. Because welcome to 2026, where Agentic AI isn't just, writing your emails anymore. It is running your entire project lifecycle autonomously.
It really is. And if your company isn't doing it, your competitors definitely are.
Which is exactly why we are doing this deep dive today. We've got this massive stack of reports and case studies on how Agentic AI, and specifically multi-agent orchestration, have gone from this experimental lab concept to an absolute enterprise necessity, especially with the new enforcement of the EU AI Act.
Yeah, we are looking at a fundamental shift in the architecture of how a business operates. I mean, for the last few years, we treated AI as a tool, right? Like a really advanced calculator or a sophisticated autocomplete.
You input a prompt, you get an output.
Right. But what we're talking about today is deploying a coordinated autonomous team of digital workers. It's a whole different ballgame.
Let's break down that shift, actually, the whole autocomplete versus autopilot thing. Because agentic AI gets thrown around in boardrooms constantly right now, but the actual mechanics are fundamentally different from the chatbots we all got used to back in, 2023 and 2024.
Oh, completely different.
So if I'm trying to wrap my head around this, could I say that if generative AI is that intern who needs a hyper-specific prompt for absolutely every task, then agentic AI is more like an experienced project manager? Like, you give them a broad goal and they just figure it out.
Well, I mean, I would actually caution against that specific comparison.
Oh, really? Why?
Because calling it an experienced project manager sort of implies human intuition, and that is definitely not what's happening under the hood.
Ah.
Yeah, a human project manager uses soft skills, they read the room, they rely on gut feelings. An agentic system uses highly rigid logic gates and continuous feedback loops. It's less like a human manager and more like a deeply complex workflow engine that can just write its own next steps.
Okay, that makes sense. It's not thinking, it's executing a loop.
Yeah.
So how does that loop actually function in practice? Say I tell an agent, research our top 3 competitors and build a pricing strategy. What is it doing that a basic chatbot wouldn't do?
Right, so a basic chatbot would generate a single static response based on its old training data, and then it would just stop. But an agentic system operates on 4 distinct pillars. The first is autonomous goal achievement.
Meaning it breaks the goal down?
Exactly. It breaks your big request down into a literal checklist of subtasks. It knows it needs to search the web, scrape pricing pages, pull internal sales data, and then synthesize it all. It doesn't need you to prompt it for each of those 4 steps.
And it's doing that by actually looking at the live environment, right?
Yeah.
Because this is where I keep seeing the term RJAX popping up. Retrieval augmented generation.
Yes, and that's the second pillar, environmental perception. RJEC is essentially giving the AI a dedicated, real-time search engine that is securely connected to your company's internal databases.
So it's not just guessing.
Right. Instead of guessing based on a data set from 2 years ago, the agent literally queries your live inventory or your current CRM data before it makes a single move.
Which is incredibly powerful, but also, frankly, slightly terrifying if it gets something wrong. I mean, what happens if it hits a wall? Like, say it tries to pull that pricing data from a competitor's website, but the website changed its layout and the API call just fails.
Well, historically, a traditional automated script would just crash, throw a 404 error, and wait for an IT guy to fix it. Right. But that brings us to the third and fourth pillars, which are decision-making authority and self-correction. This is the true magic of an agent. When that API call fails, the agent doesn't panic and it doesn't shut down.
It has a backup plan.
It has a built-in feedback loop. The error code itself is fed back into the agent's language model. The model effectively reads the error, realizes the endpoint changed, queries the database schema to find an alternate route, and then rewrites its own request to try again.
Wow.
Yeah. It only escalates to a human if it exhausts literally every logical alternative.
So it is actively debugging its own process in real time. That definitely explains why McKinsey ran the numbers recently and found that, 65% of enterprises are already piloting these systems?
Yes, the efficiency gains are just astronomical.
But as I'm picturing this, a very logical problem comes to mind. One autonomous agent quietly debugging its own web searches is great. But what if I have a marketing team running a dozen agents?
Oh, that's where it gets messy.
Right, because if I have one agent autonomously pulling customer data, another one writing the copy, and a third trying to push that copy live to a website, how are they not just stepping all over each other?
Oh, they absolutely would step on each other. They would crash the whole system. You cannot manage these digital workers individually once you scale beyond a single experimental use case.
So what's the solution?
This is where the industry moved into multi-agent orchestration. You have to build layered governance.
Layered governance.
Yeah.
What does that actually look like on a computer screen, though? Are they just isolated programs, or are they somehow aware of what the other agents are doing?
Well, if you were to look at the logs of these multi-agent systems working, it almost looks like a company Slack channel running at like 1,000 times normal speed.
Okay, that's a funny image.
It's true. You have specialized agents communicating in real time. The architecture usually involves supervisor agents whose entire job is to monitor the worker agents. The supervisor doesn't actually do the work.
It just watches the Slack channel.
Exactly. It detects conflicts and steps in if a worker agent tries to exceed its authority. You might also have resource allocation agents constantly watching the computing workload, so a rogue agent doesn't accidentally spin up massive cloud resources and cost the company a fortune over the weekend.
It's literally middle management for algorithms.
It is entirely middle management, but built-in code. However, for a supervisor agent to manage a worker agent, they have to speak the exact same language. And for a long time, that was a massive hurdle.
Because they were built by different teams.
Right. You might have an engineering team that built a data pulling agent in Python, while the marketing team bought a pre-packaged writing agent built in Rust. Natively, they can't seamlessly pass complex tasks back and forth.
So how do you prevent them from dropping tasks? Does a human developer have to sit there and write custom integration code for every single possible interaction?
They used to. But that bottleneck is exactly why the industry rapidly coalesced around the Model Context Protocol, or MCP. It was standardized by the Linux Foundation.
Okay, MCP.
Think of MCP as the universal grammar for agentic communication. If every agent uses MCP, it doesn't matter what language they were built in or what underlying AI model they use. They can natively share context, pass JSON files back and forth, and hand off tasks seamlessly.
Wait, I have to push back on this a little bit.
Sure.
I understand the convenience of a universal standard, but historically, massive tech companies hate open standards. They love building walled gardens to trap you in their ecosystem. Why wouldn't a giant cloud provider just build their own ultra-fast proprietary multi-agent ecosystem and force everyone to use it?
Because enterprise customers completely rejected that model this time around. Gartner's recent platform engineering data actually shows that over 70% of enterprises are explicitly demanding an open standard like MCP before they even sign a contract.
Really? 70%?
Yeah. Companies learned a very painful lesson during the whole cloud computing boom. They refused to be vendor locked into one provider's proprietary AI ecosystem. If they want to swap out a language model tomorrow, they need the infrastructure to remain intact.
That makes sense.
Plus, especially in Europe, there is a massive push for digital sovereignty. They do not want their entire operational architecture reliant on a closed system controlled by a foreign tech giant.
Okay, that makes total sense from a business strategy perspective. But is there a technical reason MCP is so critical?
Yes, and it is arguably the most important one. MCP inherently creates standardized message logs. Because every single interaction between agents uses the same protocol, the system automatically generates an immutable, perfectly formatted transcript of every single decision, data pull, and task handoff.
And suddenly, this isn't just about the IT department debugging a broken workflow. Standardized message logs are a legal defense mechanism.
Exactly.
Which perfectly bridges us to the absolute elephant in the room shaping all of this system design, the 2026 enforcement of the EU AI Act.
Oh, the EU AI Act is dictating everything right now. You cannot build a multi-agent system today without working backward from those regulations.
So how does the Act actually classify these systems?
It breaks AI into 3 tiers of risk. First, you have prohibited AI. This includes systems designed for mass biometric surveillance or social scoring. Those are banned entirely. You can't build them, you can't buy them.
Right, no exceptions at all. And then the next tier down.
The second tier is general purpose AI. This covers the foundation models themselves, the raw language models, before they are turned into agents. There are transparency rules there, but the burden mostly falls on the model creators, not the businesses using them.
Okay.
But the third tier is the one keeping corporate compliance officers awake at night. High-risk AI.
And high risk includes domains that are the absolute bread and butter of enterprise operations, right?
Right.
Like if you are using an agentic system to screen resumes for hiring or to evaluate credit for a loan or to manage healthcare administration, you are suddenly operating high-risk AI.
Yes. And the burden of proof to run those systems is staggering. It completely changes the engineering process. You can't just spin up a high-risk agent, see if it works, and fix it later.
Because of the documentation.
The documentation required before you even turn the system on is immense. Companies are required to conduct quarterly bias audits to legally prove their agents aren't subtly discriminating against applicants based on, age, gender, or zip code. Regulators can walk in and demand to see exactly how an autonomous agent arrived at a specific decision.
Which goes right back to why those MCP standardized message logs are a lifeline. You have to be able to pull the literal receipt. And the regulations also demand these comprehensive AI system cards, right?
Yeah, AI system cards are essentially nutritional labels for algorithms. They have to detail the agent's core logic, the exact data sets it was trained on, and its known limitations. It is a massive administrative burden.
I can imagine.
It's not surprising that surveys like the recent one from EY found over 60% of European enterprises view this compliance as a major competitive barrier.
But the regulations also force something incredibly fascinating regarding human oversight. Because for all this talk about total autonomy, the EU AI Act mandates a very strict human-in-the-loop protocol for specific triggers.
That's right.
If an autonomous agent is managing a transaction over 10,000 euros, or if its decision directly affects someone's employment status, it cannot act alone. There must be a hard-coded escalation protocol that freezes the workflow and requires a human being to review and approve the final action.
And that is a design constraint that forces better engineering. You have to design the multi-agent system to know exactly when to stop and tap a human on the shoulder.
So, hearing all of this, the quarterly bias testing, the immutable logs, the mandatory human-in-the-loop escalations, it begs a very serious question about the bottom line. Does deploying agentic AI actually save money? Or have we just invented an incredibly expensive, highly convoluted compliance headache?
It's a fair question. To really answer that, we need to look at how this plays out on the ground. Mistral AI, which is Europe's leading open-source AI company, recently architected a solution for a major German bank that was facing this exact dilemma.
Oh, the 50,000 loan applications case study.
Exactly. This bank was drowning. They needed to process over 50,000 loan applications a year. They had to navigate the strict new EU AI Act, existing GDPR privacy laws, and standard banking directives, all while trying to speed up a manual review process that was literally crippling their growth.
So how did Mistral actually solve this? Because building one massive loan approval AI sounds like a regulatory nightmare. I mean, if it denies a loan, how do you even explain to the regulators what went wrong inside a giant neural network?
You can't. And that is why they didn't build one massive AI. They used multi-agent orchestration. They broke the loan approval process down and deployed 3 highly specialized agents.
Okay, walk me through the 3 agents.
First, they built a data verification agent. Its only job was to autonomously cross-reference the applicant's submitted data against GDPR-compliant databases.
If an applicant forgets to include, like, a specific tax form, the data agent just sees the missing JSON field, flags it, and maybe automatically emails the applicant to ask for it, without a human loan officer ever having to look at the file.
Exactly. It cleans the pipeline. Once the data is verified, it hands the file off to the second agent, the risk assessment agent. And this is where the engineering gets brilliant. They specifically designed this agent using transparent, rule-based decision trees.
They deliberately avoided neural networks?
Yes. They chose not to use complex black box neural networks.
I want to highlight that distinction for a second because it is so important for you listening. A neural network makes a decision by passing data through millions of invisible, unreadable weights and parameters. You feed it data, and you just get a yes or no at the end. You have no idea how it got there. But a decision tree leaves a literal paper trail.
Right. It operates on strict logic. Like, if income is greater than X and debt to income is less than Y, then proceed to step Z. Regulators can read a decision tree like a map.
Which is called explainability by design, right?
Exactly. Because under the EU AI Act, if a citizen is denied a loan, the bank is legally required to explain exactly why. The bank can just print out the agent's decision tree log and show them the exact logic gate where the denial happened.
That is brilliant. And what was the third agent?
The third was a dedicated compliance agent. It basically sat above the other two, constantly looking over their shoulders. It monitored the risk assessment agent's decisions in real time to calculate bias metrics, making sure that the approval rates weren't mysteriously skewing against a certain demographic. It logged every single step perfectly for the regulators.
And the results of this case study are just staggering. I mean, the bank dropped its processing time by 60%, and when the regulatory audits came around, the bank passed with zero findings. The multi-agent system essentially generated its own perfect compliance report.
It did.
But what really stands out is the financial impact.
Mm-hmm.
A manual human review of a loan application used to cost the bank €3.50 per application. The agentic system brought that operating cost down to 15 cents.
15 cents. I mean, that margin changes the entire business model. Suddenly, the bank was able to process complex, lower-value loan cases that they used to reject outright because the human labor required to vet them cost more than the profit of the loan itself.
Okay, but let's be realistic about the economics here. Dropping a per-transaction cost from $3.50 to 15 cents sounds amazing, but that doesn't happen for free.
Right.
What does it actually cost to build a compliant multi-agent system from scratch?
Well, the initial capital expenditure is significant. If a company uses an enterprise framework provider, someone like AetherLink, for instance, they are looking at anywhere from 50,000 to 200,000 euros in upfront development and integration costs. And that is just to get the system built and tested.
And then you have the recurring costs. You have to pay for the cloud compute, the API calls, the continuous model training, and all that mandatory compliance monitoring.
Exactly.
The data shows that runs another 35,000 to 175,000 euros annually. So this is definitely not a cheap software subscription.
No, it is a serious infrastructure investment. But the economic models we are seeing show that the break-even point usually hits within 18 to 24 months, provided the transaction volume is high enough. If your company is only processing 10 complex loans a month, this architecture doesn't make sense. Keep your human staff. But if you need to process 50,000 loans, or if you need to analyze 10,000 customer service tickets a week, the math flips and the return on investment becomes undeniable.
Which inevitably brings us back to you, the listener, and your career. When a company realizes they can drop processing costs by that much, what happens to the people who used to do that processing? McKinsey ran the data on European markets, and they project that by 2028, 35% of all office work is eligible for either deep augmentation or outright replacement by agentic systems.
Yeah.
35%. That is a massive chunk of the daily grind.
That number can sound incredibly alarming, but context is crucial here. We are not just looking at a mass elimination of human workers, we are looking at a fundamental workforce transformation.
How so?
Well, let's look back at that German bank. When their processing time dropped by 60%, they didn't just fire all their loan officers. Instead, they took those highly trained humans and reassigned them.
Right, because the agents handle the tedious data verification and the initial risk math. But a human still has to handle the nuance.
Exactly. The bank shifted their human workforce into relationship management and complex problem solving. When that 10,000 euro human-in-the-loop trigger gets hit, or when a high-net-worth client has a totally unique edge case financial situation that doesn't fit into the agent's decision tree, a human steps in.
The algorithms handle the volume, the humans handle the empathy, the trust, and the exceptions.
Precisely.
Well, we have covered a massive amount of ground today, from paralyzed assistants to complex compliance webs. So what is the core takeaway here? For me, the big lesson is that agentic AI is not just a software update that you casually install on a Friday afternoon. It is a complete architectural shift for a business.
100%.
In 2026, if you treat AI governance and EU compliance as an afterthought, like something you try to awkwardly bolt onto the end of a project to appease the lawyers, your deployment will sink. But if you build explainability by design into the actual code from day one, you aren't just ticking regulatory boxes. You are creating a massively scalable, highly efficient competitive advantage.
I think that captures it perfectly. The technology and the regulation are no longer in opposition. They are informing each other. And as we wrap up, I really want to leave you with a final thought to ponder.
Let's hear it.
We talked about how companies are managing this scale through multi-agent orchestration. We have worker agents executing the tasks. We have supervisor agents managing the workers. We have resource agents managing the budgets, and compliance agents monitoring everyone else's behavior. If you zoom out, we are essentially building entirely autonomous, self-correcting corporate bureaucracies in the cloud. At what point do the human executives at the top of these companies look at their dashboards and realize they aren't actually managing a human workforce anymore, but simply managing the algorithms that do?
Wow, that is a wild thought. Because it means that the blank stare of the assistant we talked about at the beginning, it hasn't just vanished. It has been replaced by a digital team that might just be running the company's daily operations better, faster, and more compliantly than we ever could.